Hello and welcome to my presentation. In this video, I will be discussing the application of diode in practical electronic circuit, specifically focusing on their role in rectifier and clipper circuit. These are fundamental components in many electronic systems, and understanding how they function is essential for anyone studying electronics. The objectives in this assignment is to demonstrate our knowledge and practical understanding of how diodes work in controlling and shaping electrical signal. We will walk through circuit diagrams, explain how the circuit operates, and show experimental setup to support our explanation. A rectifier is a fundamental electronic circuit used to convert alternating current or AC into direct current or DC. This process is essential because many electronic devices, such as smartphones, laptops, and radios, operate on DC power, while the electricity from our wall socket is AC. Without rectifier, it would be impossible to power this device safely and efficiently. There are two main types of rectifier: half-wave and full-wave rectifier. Let's take a closer look at each. We will start with the half-wave rectifier. This circuit uses a single diode and a resistor. When an AC input is applied, only the positive half cycle of the signal are allowed to pass through this diode, while the negative half cycle are blocked. This results in pulsating DC output, which means the currents only flow during the positive cycle and stop during negative. One major drawback that is its efficient. We are only using half of the input signals and the output still has lot of ripple and fluctuation. Next, we have the full wave rectifier, which is much more efficient. There are two types. One uses a center tap transformer and two diodes. The other uses a bridge rectifier made from 4 diodes. The bridge rectifier is more common because it doesn't require center tap transformer. In a full wave rectifier, both half of the AC signal are used. During this positive half wave, two of the diodes conducts, and during the negative half cycle, the other two conduct. But they all direct the current in the same direction through the load. This results in more continuous and stable DC output compared to the half-wave version. Here's an important part. In most practical applications, a capacitor is added after the rectifier. This is called a filter capacitor, and its job is to smooth out the output by charging during the peak and discharging during the dips. This significantly reduces the ripple, producing a much more continuous DC voltage. In this experiment, I observed the waveform of both rectifier using oscilloscope. To sum it up, the half-wave rectifier is a simpler but less efficient. The full-wave rectifier is more complex but provides a smoother, more usable DC output. Both circuits are essential for powering DC electronics from AC source, and the diodes play the key role by allowing current to flow in only one direction. Now, let's move on to the clipper circuit, which are also known as limiter circuit. These circuits are used to clip or cut off part of the input signal without distorting the remaining waveform. This is useful when we want to limit the voltage level of a signal. There are different types of clippers: series and parallel. The series clipper place the diode in series with the load, while the parallel clipper place it in parallel We can also use bias clipper where DC voltage is added in a series with the diode to clip at specific voltage level. In a simple clipper circuit using a diode and a resistor, if we apply an AC input, the diode will conduct only when the input voltage reaches a certain level. This cut off or limits the output voltage to a certain range. We will include diagram showing both positive and negative clipping and explain how changing the orientation of the diode affects which part of the waveform is clipped. This helps in designing circuit where signal control is important, such as waveform shaping, communication system, and audio processing. Clipper circuits are used in many real-world applications. In communication system, they prevent signal from exceeding maximum voltage and causing distortion. In power electronics, they protect device from voltage spike. In audio system, they use the shape waveform and eliminate unwanted noise. To summarize, clipper shape the signal by removing unwanted voltage level. They built using diodes, sometimes DC bias voltage. They are simple, reliable, and essential in many electronic systems. Overall, clipper circuits are another great example of how we can control the behavior of signal using just a few components. For the half-wave rectifier, we use 12K ohm resistor and diode. Now, we take BNC to crocodile clip connector that are connected to channel 1 and connect the neutral to earth. After that, the live clip on the diode. Then, we repeat the same method for the function generator. Now, we take another BNC to crocodile and put it on channel 2 and connect the live clip to the opposite of the diode. Then, put the neutral clip to earth. And now, as you can see, channel 1 will display input wave and channel 2 will display output wave. First, we take the positive clip from the power supply and put it on the point A on the diode. Alright, after we done that, we will take the negative clip and we will put it on the point B of the diode. After that, we will connect BNC to crocodile clip to oscilloscope channel 1. And then, we will connect the red clip to the point C and the negative clip to the point D of the resistor. And this is the diagram of the full wave rectifier that show us where the point A, B, C and D is. Lastly, this is the output that are generated from the full wave rectifier circuit. And now I'm going to show you the clipper circuit, and this is the power supply set. And this is the setting for the channel 1 where we set the volt per division to 1 volt, and channel 2 where we set the volt per division to 1 volt, and we set the time per division to 0.5 millisecond. For the oscilloscope, And this is the setup where we use 500 Hz frequency for the function generator. And this is the setup that we already made for the clipper circuit. And this is the clipper circuit diagram that I use as a reference to make this setup. And as you can see, this is the waveform that I generated from this oscilloscope from this setup. In conclusion, this practical assignment has helped me to understand how diodes are used in a real-world electronic circuits. The rectifier circuit shows us how AC can be converted into usable DC for device, while the clipper circuit demonstrates how we can control signal level effectively. By building and testing this circuit, we learn about the behavior of diodes under different conditions and how important they are in shaping and directing current flow. This concept form the foundation of many applications in the power supplies, communication system, and signal processing. And I think that's all for this video. Thank you for watching.